Chico is a graduate of SIUE. I'm an SIUE alum, manufacturing engineering, and recently received a grant from the Highland, Illinois community, one of the gigabit cities in our area, to bring some of his office and manufacturing space to Highland. So he's located here and also in Highland, Illinois. So dynamic young man, got a lot going for him, so we'll turn it over to Chico.
All right, can everybody hear me? Good, good. So again, my name is Chico Weber. I'm the CEO of Squarefruit Labs. We're a very small tech and 3D printing company. We focus a lot with robotics. We've really tried to integrate that type of technology and research and development into the products that we make. And some of the machines that you're seeing around us, including the printers, some of these boxes that I'll explain exactly what's going on inside of them, and some of the robots and even hydroponic systems that we have growing are all as a result of us being able to have 3D printing as a part of our business. Maybe that's something that you guys are considering as well. Maybe you want to know exactly what type of printing technology is available, what's the best type for the clients that you have in supply, and exactly what type of clients you're trying to grab by offering 3D printing. And that was something that us as a small startup we really struggled with, and we tried to figure out exactly how to pivot around our own clients, around our own business. Because honestly, when we first started off, we were in renewable energy. And BK remembers this. We were in my basement. We had a few printers, and we had gotten a small grant actually from SIUE to keep funding that research. But the truth was, having 3D printing and having these printers actually part of our community and actually developing as we were starting as a business really helped our company launch and allowed us to actually dive deeper into more into robotics, more into technical fields that a lot of clients were really looking for. People wanted prototypes, they wanted end-use items, they want to supplement exactly half of their supplies with 3D printed components. They wanted to learn how to make it cheaper and how to actually cut out a lot of the middlemen for the consumer level products that they were really purchasing. And that was something that we really focused on. So right now, I don't actually have a full presentation, so I'm just going to talk to you guys about exactly what the 3D printing is and the different forms that are available, how you guys can really integrate that with your businesses. And at the end of this presentation, I do have something that's written up that we can have sent out to everybody who's here that would like to have a hard copy of something emailed to them that explains all the different things that we're going to talk about in this presentation for you guys. So depending on what industry you're in, you may be working with plastics, you may be working with metals, you may be working with some types of bio-tissue. You may not even be working with anything like that. You might just be dealing with clients and consulting. But regardless of which one you're dealing with, 3D printing will eventually hit you. And if you're already seeing the boom that's happening online, you're already seeing this type of development that's going on and why it's becoming such a huge dynamic industry changer, it's because it's getting more and more affordable. This is technology that's really been around since the 80s. And since the original machines came out, they were quite expensive, and they were really only offered to industry leaders and developers that had enough money that could afford $1 million worth of this type of technology. But due to recent open source hardware development, due to newer pushes towards making the software, making the hardware, making the production system around 3D printing cheaper, we can now really afford this type of technology. Some of the machines that you're seeing around you, including the white ones right over here, those are $500 a piece. It's quite cheap, and there's a huge range of types of printers, and some of them, including the ones that you're seeing, are what we call FDM. So they work with thermoplastics, the cheapest form that are available, and they're what a lot of consumers are offering and using right now. So if you're working with the types of prototypes where you're not really sure exactly what type of systems you want to build, maybe you want to work with small build envelopes, maybe you're not quite sure exactly what type of software you want to use, or maybe you haven't quite even decided that you want to use software to do this type of prototyping. 3D printing, especially going down this route with smaller, cheaper thermoplastics, is an easy entry point. So for us, that was something that we had done because we were much smaller and we needed to be able to offer prototypes, even ones that were made out of plastic, and that's what a lot of our customers were looking for. They wanted prototypes for, now we're getting clients that are looking for stuff like home restoration. We have some that are looking even for biotech industries. We have some now for agriculture, and these are all due to like using thermoplastics out of very affordable FDM machines. When we go further on down, like the line, we start talking about stuff that's a little bit more expensive. There's another term that we use for selective laser sintering. That's another one that you guys have heard. It actually has to do with a laser that's melting certain powders. And those powders could be anywhere from plastics to metals to even some types of wood and certain resin filaments. What you actually get out of it is a higher resolution print part, but at the end of it, it costs quite a bit more, and those machines are still a bit more expensive. But they're actually one of the leading ones that came out initially with 3D printing. So when we first talk about like what's available for consumers, those are still on the industrial end. FDM is still on the consumer level. But what's still available on the consumer level now is what we call stereolithography, SLA. And that technology was the original 3D printing tech that came out. What's available through that is actually UV curable resin. And that resin actually allows through either if it's not laser projection or if it's actually UV lasers, you can actually draw shapes from the ground up. That's not something that we have, like we could show you here, but that technology used to be quite expensive, but it's actually getting cheaper. For less than $5,000 now, you can actually purchase these machines. And now there's a newer piece of tech came out. If you guys ever heard of Carbon 3D, it was like a big thing that they launched a few days ago, but it's continuous light production systems, and that allows even faster printing. And so as you get deeper into this tech, we kind of focus a little bit more on like the research and development behind it for our clients. But for you guys, I kind of want to know exactly what it is you guys are looking for. Maybe I could even pick a few guys from the room as well. If you're you came here just because someone dragged you here, or if you're actually interested in purchasing a system, or if you're looking into integrating this for a company that you may be working with. So I'm going to start with you.
We're actually a manufacturer of packaging, and as a result of that, we have to make molds before we start doing it, because it's custom formed. And so we're looking at it really for two purposes. One is development, so we can make a physical part before having to make a mold. But we're actually continuing to push the envelope and seeing if we can replace molds, which are in essence one-off subtractive manufacturing, if you will, or one-off additive manufacturing. Actually looking at some of the SLS and equipment straps.
Okay. Cool.
Can you repeat the question for those in the back?
Yeah, so repeat the question or the...
Yeah, the question.
No, he asked how we're looking at it. We're a packaging manufacturer, custom formed, and as a result of that, we have to do one-off molding guides before we can actually create a part. So we're looking at the technology for two purposes. One is to just make one-off samples that we can physically show customers before we, kind of that bridge between a 3D design and actual fabrication of the part. But we're also looking at it, like Chico was saying, from the SLS kind of technology, where we would replace our one-off molding guides that are, as they're called, subtractive manufacturing, CNC, with kind of a one-off additive manufacturing like an SLS, or SLS.
So when you want to show your prototypes now, what options do you have?
We have to actually make them kind of a temporary or sacrificial mold process. So we have a way to do it, but yeah, it's expensive, it's time consuming, and so the SLA, some of those kind of technologies give us the ability to kind of do it a little quicker. So it's still, everything still presents a certain obstacle or challenge, but we actually looked at this technology, as Chico said, it's been around since the 80s. We looked at it probably 12 to 15 years ago. We're still trying to figure out how to incorporate it into our business.
Yeah, so that's a great example. And oftentimes mold making is quite extensive. You have to outsource that to someone else unless you directly have that capability. And it costs you several times more than just purchasing a printer that could produce any type of mold of variable sizes on the spot directly in-house for you. So that's something we've had a lot of clients actually come to us with similar things, various prototypes that they've wanted to make, and they want to get it completely prepared for injection molding. They even want the molds made on top of the prototype. And that's something where, you know, we could still make the prototype, we can even make the molds, and it's all due to a very affordable machine that previously required a lot of machining, a lot of tooling, something that was quite expensive, but can now really be done in-house, regardless of what your company is currently doing. Yes?
Yeah, question for Brian. Making a mold, in your case, roughly how many man hours do you think a process like this can take out of that mold?
It moves some of those man hours from, you know, what we'll call traditional manual machining and stuff to a little more programming. But once programmed, most of that mold can be pretty much programmed overnight and never fabricated, printed, whatever term you want to kind of use, plus a little cleanup. So it's a pretty significant.
So your CAD component doesn't change much?
The development of the CAD doesn't change much. That's still exactly the same, but the design of the actual mold changes. And again, that's probably industry by industry. We have a pretty extensive amount of additional detail work compared to like a thermoform or injection molded plastic kind of technology. So I don't know. We're still trying to figure out what the exact percentage decrease is. We believe it's there. We're still trying to put our thumb on what that actual number is just yet. So.
Yeah, if you guys are interested in the process that it takes for most people to go from the computer, from CAD software, directly into 3D printing, I'll give you guys like a short little brief on that from the computer there, because honestly, even like this part that we just finished while giving the talk, everything just goes on these little SD cards. So it's really easy to just transfer it over. I just go over to my computer. I can even download pre-made files, and once it's made, it's made. I go back, I can hit print as many times as I want, and the machine's going to continuously produce it. I mean, I'm still working because the printers keep going even if I'm talking. And that works for most printers, and now they're getting wireless. So some of the systems that you're seeing, you no longer have to worry about anybody even like being there present to operate them. If your cost is really based on like man hours, and that's where you're trying to like recoup a lot of that value in, you can have an automated system. The machines work wirelessly, and it's quite affordable, and it's pretty standard set now for a lot of the newer printers to be able to just do that. And most of the tech now is being developed into building better CAD software that can interact and slice the parts a lot better for being able to print. All right, I'm going to pick somebody else. There you go. Go ahead.
So I'll try to say this for everybody. Chico, I'm, among other things, a professor at UMSL.
Yeah.
I do research in cellular manufacturing.
Okay.
So for everybody, most of you all know this, multiple machines, all lined up to make a finished product in reasonably high value. So one interest I have for being here is understanding when that, and I realize you're an evangelist, so let's get out of prototyping for a moment and talk about volume manufacturing and the materials, in addition to the machinery, finishing operations if needed. I don't know. But I'm sort of wondering when a company would, I'm a supply chain professor, when the company would give up its supply chain and just, so instead of having vendors that send you precision components that you use in precision assemblies of reasonably high volume, when do you just buy a printer and stick that printer right on your assembly line and print off that part? I know it's not happening yet, or in low volume applications. So talk a little bit about maybe the crossover, the material cost. Is this 5 years out, 10 years out? I know it's not today, except in some very low volume applications.
Yeah, so the discussion on cellular manufacturing, being able to work with, I'm guessing, a lot of biological material. There's a lot of liability as well with certain...
No, he's talking about cellular in the sense that a group of
cells.
cells.
Oh, it work cells. Okay, workstations.
I'm in business school, sorry, not in biology.
I came from Idea Labs.
Right.
They're all biomedical engineers. So when you say cellular manufacturing, I go to the genetics lab to do that. Okay, so in terms of doing that, it's a cost analysis. So when's your break-even point? And that's really dependent on the material that the printer is consuming itself, and that's really dependent on the precision that you want out of that machine. So if the precision can only be offered by a manufacturer that's developing those high-precision tools, then that's what you're going to have to stick with until a printer comes out with the capabilities for you. And I can tell you there's already printers with that capability. It's just the bill that you're going to flip for is quite high, I would imagine, if you're looking for a certain level of precision. So, but once you acquire that machine, your only costs are the materials that you are paying for to run through that machine, and actually the hours that someone else will have to use for it, because those are still industrial machines, and those still use their own proprietary software right now. And I can tell you that a lot of the lower ends, like the ones here, are they're a little gimmicky, and they may not be exactly what you're looking for that type of work. So it's really, it's a cost analysis. It's the same thing I would work with any other type of machining process, any other type of system. If you do need something that requires like a Six Sigma level of certification, if you're going for some kind of ISO standardization, and you have 3D printers in there, they're so new they may not be part of the process that you're looking for, and they may just be a system that you have on the side that is waiting to become certifiable for that technology. But as of right now, a lot of that printing tech isn't. And so being able to move in that type of direction is really dependent on if that's a cost that you can bear for now, knowing that the precision tools that you're buying may eventually cost too much and the printer price will drop down. So that's how I would look at it.
What are some of the things that are changing in technologies that are driving towards higher productivity?
Productivity, or
yeah. So as you move from prototyping to production type equipment, what types of technologies are out there that are increasing speed, increasing build envelopes?
Yeah, so
capabilities to do multi-cavities, at one time instead of just one piece. What types of new technologies are we heading towards that are going to allow that to happen?
Yeah, some of it's actually, I would call it rebranding of older versions of printers. What you're really looking for is machines that print faster. When it comes down to injection molding and being able to have batch runs of parts, people are very used to quick turnaround once the molds are set, once the product is set up for a station, and then once, even if it's a job shop and you've got your own set of tools already established, you have your own production run that you were going to do for a client, then that's something that people have this understanding that's going to be very quick. And it's very hard to understand that that tiny little part that came out of the printer could cost 3 hours of time. What's the value of that 3 hours of time? Well, I mean, for me, it's direct being able to produce it in-house for me without going to an outside source. I won't need 10,000 of them. I may only need 5. But the guy who's going to do it doesn't care if it's 5 or 10,000. He's going to charge me the same rate plus an incremental price for each one that's being produced. And so the quick turnaround is is something that everybody's trying to get around with these machines. You're seeing the lower end consumer products that are trying to produce the printers faster. They're trying to make them so they produce components with, I would say, higher precision. Something that FDM technology like this stuff is probably going to become obsolete, and it's going to move towards laser deposition. And that's a newer thing actually for using higher precision for metals, being able to deposit materials in a powder form with lasers, a little bit different than sintering, but in a very similar fashion that you'll actually get a metal part. And so being able to combine both subtractive and additive manufacturing would also be another step. And there's a lot of German companies now that are actually jumping on board, and a few Japanese ones that have machines that can do that. Yeah.
Can you talk a little bit about the range of materials? I mean, I'm coming in, my assumption is it's polymer plastic based, but where is it headed and where are we right now in terms of what kinds of material a finished product it can produce?
Yeah, so you can produce, so a lot of polymers. Thermoplastics are quite common. We're moving more into wood resins is another one for certain people. And then you've got an entire range of metals from aluminum to brass to grades of titanium. There's certain forms of steel that you can use as well. Gold, silver, platinum. You've got an entire spectrum of minerals that you can really actually use. And you can also print the other type of living cells and tissue, which is now becoming a bigger aspect of Organovo, if you've been following that company. And they're anticipating the next 10 years, fully functional organs, especially the liver, to be one of the first things that come out of them. So these printers all use their own techniques, but the process is very similar. the way it deposits material is quite similar. And so when you get down to it, that's really the direction that we can go in. Yeah.
I mean, is the integrity of the finished product the same as the raw material? So if you're using steel, what you'll get out of it is the same tensile strength, et cetera, that the raw material had? There's no...
Yeah, so initially that was an issue. When we were talking about being able to produce perhaps like jet parts,
Yeah.
Thermal properties weren't quite the same for titanium that was machined versus titanium that was printed. That has recently been proved to be no longer an issue since NASA now uses some of those components, and now that there's stronger plastics, self-reinforcing thermoplastics even, that can be printed, those materials are being used in aircrafts. So if you've heard anything about the new ventilation systems that are being printed, they're much cheaper, but they're also much stronger, and they've got all the mounts built in, and that's why they've chosen to use that tech, and they've chosen to use that particular type of plastic to replace what was originally there.
There was actually a story about Tesla, I think it was Elon Musk, SpaceX, that printed an entire rocket that they launched into space utilizing the 3D technology.
It wasn't the one that had a fail.
But they got that.
Because he tweeted about it afterwards.
Yesterday, I think.
We do have some parts coming around too, so please pass them around and take a look.
Can you kind of maybe highlight what are really the differences? I'm a little bit older, but I remember SLA, right, stereolithography. What are the really basic differences with stereolithography and 3D printing? You know, is it just the technique, other than cost? But what are the differences between those technologies?
Yeah, so it gets down to the process. When we're talking with stereolithography, there's a resin that is actually in a pool, and the geometry for that varies a little bit depending on how you're making it, but it actually uses UV light to cure a part layer by layer.
Okay.
So then when you're done, you still get a solid part. It's made of a particular type of resin, and but those tend to be a much cleaner, much smoother surface, so you tend to get a much better resolution, and you can really, a lot of people are using it for smaller parts, but the industry has been allowing it to be done for quite a wide range of it. The other use for lasers and actually powder is a whole nother range. So that requires a lot of heat and being able to actually sinter and melt, whether it's going to be plastic or metal powders together to actually combine that. And then if you're still wanting to use powders, there's other ways of actually depositing like inkjet printers, layer by layer, and that's where you're actually able to cure stuff like plaster. Something like the Objet, I think it's like the 660 series of printers. They actually use a plaster, and something similar to how like we've all been used to like two-dimensional printers and how they just like deposit. It does a very similar fashion, but it just has a third axis where it moves and lays down more powder and actually keeps combining that until you have a cured part. And those are the common ones. I mean, there's FDM as well, and that's the one where we're just melting plastic and drawing that layer by layer from the ground up. It's the cheapest one, but you're definitely not getting the highest resolution out of it. Yeah.
This is all very exciting, and I know that often the cost, long-term for any type of equipment, is in the maintenance and repair and operation of it. So I guess I've got a two-part question is, what is the cost to maintain? So you buy the new piece of equipment, you got the 3D printer, you bring it inside, and then something happens. How do you address that? What is the cost long term? Are we too much in the front end of developing technology to really make that investment? And then my other piece of that was, how do you give somebody within the facility the skill set to maintain that equipment? Is there any type of certification or just making sure that you are able to fully utilize that equipment and you're keeping costs for maintaining it down?
Yeah, the cost, I would say, for the industrial machines is quite high. Obviously, the cost of these types are lower, but they fail a lot more often. But when they do fail, they're easy to fix. When it's more industrial ones, you definitely, the way that they have an agreement, most likely if you're going to be purchasing this from a company like Stratasys or Objet, or even if you're using something that's similar to how Shapeways, how they have their network set up for printing, they're going to have their own certified technician come in to do that repair for you, and it's not cheap. And But it really is, it's a cost benefit thing. You got to see if like having that printer in-house, is it producing parts that are, paying a lot better than, the maintenance cost for that machine. And more times than not, it is. And it's really dependent on your clients. Because certain clients, the printer is capable of producing a lot of different shapes, is really what it comes down to. Certain clients want a very specific thing, and certain clients are open to certain types of agreements that you can really adjust what comes out of those machines. And because of that, you can have a lot of high-value components come out of a high-value machine, but you can also have a lot of low-value components coming out of a high-value machine. And that's really dependent on how you treat the industry that you're working with, and if that's something that's worth it for you guys.
Do those costs get moved downstream to the customer? So let's say you do have a contract with a manufacturer to maintain the equipment. Do you find that those costs are kind of parlayed into the product, the finished product?
I would say a lot of companies absorb that cost themselves. I don't know very many that try to translate that down to the customer. It's like a respect thing, but I'm sure it happens. Even if there's good days and bad days with injection molding machines, but it's really dependent on the company if they're going to be doing that. And some do, and some don't make that as part of their policy. But I think a lot of the companies that do have the prototyping machines, what they're producing is such low volume that if the failure happens probably partway through one of their clients' products, because that's when it's running. And usually they're just going to reset it and absorb that cost and actually just reset the print and do it again. So they're trying to break even on it if possible. So yeah.
Yes. You're talking about metals and lasers and everything like that. How complex can it get? Like I know you're talking about. You were talking about SpaceX and they built all the parts for them. Mm-hmm. Like I'm in power generation, so say I wanted to go and use that technology and print out a piston. How the pistons like 100 pounds. Can they do something that size yet?
Yes, they can. They can print much larger than that as well.
Okay, now how theoretical or how far away from the future are we from? Like I said, some of these engines I work with are very, very large. So a turbocharger is $250,000. All right, I don't want to hold that in inventory. I just want to get the printer. How far away is it from just something? Hey, this blew up. All right, no problem. My buddies from Squarefruit Labs are going to print me out this part. I can get it to you within 5 days. How far away are we from that? Technology.
Yeah, I think the technology is already available. The headache that comes with it is actual government regulation on whether or not that part can be certified for you to distribute it to somebody else to operate at the same manner as something that was machined or something that was actually milled out or any other way that you were producing or injection molded. And a lot of that is just because the tech is so new that the law is moving at a much slower pace, obviously, and most companies and most printers are capable of offering that in that field, especially if they're coming from a larger company that has already set their goal in manufacturing and machining with utilization of 3D printers. It's just some of these cannot be offered as end-use items, and they're definitely that's just because of a lot of the regulations that are out there. And there's, doing the test, you'll definitely find that they can resist it, but that's kind of the big headache with it right now. Yeah.
To address your metals, one of the problems is I've been doing I had a manufacturer for a year. One of the problems is that your metal is fully dense. That's what they advertise, fully dense metal. But it has no grain structure like a rock material or a cast material. Without grain structure, you have electrical strengths that are involved here, especially if you're making pistons and pony rings. And that's why certification we talked about is so important with that. Now, he also mentioned the laws being slow to change. People don't realize that Walter Reed Medical Center, Michael Air Force Base, has been using 3D printing for 20 years to make skulls, scans of tumors, to make casting implants for titanium for head wounds. And the thing is, we can't use them in the medical industry out here because of the laws changing so slow there's no insurance code for 3D printing. But the airport, the New York airport is going to use it easily and hand it.
We're talking about titanium, metals, all these things. Which my question is, so it's done in the atmosphere then?
I'm sorry.
Atmosphere such as titanium, oxygen sensitive. You run them under helium, argon, you know, industrial gas.
Yeah, they do.
Okay.
You gas your pump chamber out, put them in the bag because of the dust. Powder is so fine,
Right. Which is good news because I know.
otherwise
gas-
it's unsafe.
Right, exactly. And I, you know, was it just a prototype? Basically, that's a big advantage. If it's just a prototype, then I don't need to mean it. If it's a prototype, that's one thing. If it's going to grain structure, this and that, then you're talking about introduction of gas.
Yeah, a lot of the machines, familiar with them, especially like the SLS, they introduce I would say non-combustible gases. Some of them switch out, but directly in the nozzle to prevent like some weird deformations that happen. Sure. There's delamination, stuff like that happens when you're printing, but also in the chambers while they're working, just because of safety hazards. Right. More than just like for settling, but also just so that like the powders aren't actually reacting to certain things that could cause like a faulty part. Sure. Yeah.
Read that you're interviewing the Business Journal.
Oh.
Can you talk a little bit about what you're doing and the persona with integrating the robotic arm?
Yeah, so this is Persona. We've been doing a lot of development. We took out some of the components, so it's just sitting here now. But the machine itself is designed to perform a lot of different systems that you're really familiar with, 7 degree of freedom, even 8 degree of freedom robotic arms. Something that Universal Robotics has been quite adamant in demonstrating for introduction to smaller machine shops. We're trying to make it more of a consumer-friendly product, integrate a little bit more with Google search developments, and that's something that BK has been working on right now. But also 3D printing directly using the robotic arm rather than what we call the gantry system, which is the traditional XYZ movement. So a lot of European nations now, I would say, especially like France, have been very forward with using robotic arms to perform 3D printing versus using these, I would say, more microwave style systems. And the reason why is because you can have a much smaller footprint using a much larger machine, and you can produce very unique components, including scaffolding for parts without actually viewing them layer by layer. And it's something that we're calling uniform printing for now, but it's one of the newer developments that are really taking shape.
Chico, could you talk a little bit about impact on supply chain? We hear this theory where a van pulls up in front of your house and goes in and checks your dishwasher and finds a part and comes out and prints it and puts it in, and there's a big impact on supply chain from that perspective. Can you talk about how realistic that is, timeline, how things like that are progressing?
Yeah, so again, it really does come back down to liabilities and insurance with the components. The capability is definitely there technologically. I would say from certain perspectives, not that I'm speaking on behalf of BJC, but I definitely know that there are some development on their end. This is for medical grade replacement parts for some of their machines where they are outsourcing them. They break down just like dishwashers do and a lot of other stuff, but the price is so much higher because they're getting those components certified at a different level. And because of that, they're wondering how can we replace these things with 3D printed components? How can we keep everything as a digital catalog so that all we have to do is download and hit print and we have those parts available and we can cut out that interference from production. And right now that technology is available, but being able to release that to the public is it's still in the works, but I think it's something that'll happen soon.
Yeah, sorry, I was reading Popular Science a few months back, and they were talking about in Columbia a company that uses 3D printing to print out beef patties. how far, I mean, now they said it's good and everything like that, you know, they've eaten them, I mean, it's not, how far away is it from, you know, next time we have a meeting with you, and you just go around, well, what do you eat, you know, and I say, I just want a burger, and then you're like, ooh, turn down a burger and throw it on the grill for me. How far away are we from that, and just being, you know, that quick, just, you know, just bang, bang, you know, like Back to the Future type stuff. Put a little seed in, I mean, grass different, you know, then boom, you got a turkey. How far away from there?
Yeah, I'd love to open that restaurant that just 3D prints food.
Well, that's what I'm thinking too.
Well, they make one of those pancakes, you put the batter in, does the shapes on a grill. They make, whatever your kids draw, they can reproduce, they make that one now. And they also make one, put chocolate in, you make candy bars, custom made, things like that. So, but it's take that raw material and put it in, now if you're gonna grow the wheat protein, therefore you know, it's not grain fed, you start to lose, I don't know.
I mean, the one, we were at the Consumer Electronics Show, not this most recently, maybe 2 years ago, and one of the 3D technology companies, one of the machine manufacturers, was focusing on food, printing of food. And the logic was this, you remember back to your wedding, you had a bride and groom on top of the cake, and it was the stock bride and groom. They have a technology where it's a full size, the bride walks through a 3D scanner, the groom walks through a 3D scanner, and then they print you two standing on top of the cake out of sugar, so you in essence can eat yourself.
Yeah, I would say like our senior design project was actually a chocolate printer. So that's kind of like one of the unique things. That's where we started with it. People liked chocolate, so it worked there. But sugar is a big thing now because it's very similar to like traditional printing with resin. So they can just spray water down and actually cure like sugar powder and form very intricate sugar cubes. I mean, they dissolve instantly in your coffee, but it's a huge seller for certain restaurants now, actually. It's getting a printer that works in the culinary industry. Yeah. Okay. Anybody? You? Choice.
Got one back here.
Got one back here?
Yeah.
Okay. Well, I got three. Okay, I'll go you first.
All right, so this would be general feedback. So, Director of Engineering for a mining and power company, we make big mineral processing equipment. You keep talking about all the government regulations. I'm pretty sure I could pick apart and put it in there. I have none governing it, and 60% is export. So, first of it is, are you guys working outside the automotive, biotech? Because I understand how much regulation is there. And there's industries that could use it that don't. You're essentially self-insuring because you got to warranty a product that's sitting in the middle of nowhere. If it breaks, it just breaks. It costs money. And then the use I see, at least for my industry long term, we're really low volume, high mix. We're doing a lot of removing metal off of a big hunk of steel. Yeah. That obviously, where we can justify using forgings and castings, we still wait 4 to 8 weeks for a delivery, where you're just sitting around waiting for material. And we're struggling right now meeting lead times. And the third thing is we have depots and parts warehouses, really remote areas out in the middle of Ural Mountains in Russia. I mean, it'd be great if I could just ship off an order and print it out there instead of, especially in terms of proprietary designs, in one of the Asia markets. The second we go and start manufacturing there, we find that all of a sudden you can get our parts up in other areas. So just the control of knowledge. Right now we try to manufacture these here, but like I said, you're waiting for parts, you're making them, and you're shipping them across the ocean. You air freight it, you ruin these margins. So any thoughts around security and the ability to basically just transmit and have a home base that owns it and it's just printing remotely, and really just how close we are for higher strength steels to essentially replace the CNC machine parts?
Yeah, I'd say they're already at the point where they can have a one-for-one replacement for metal parts that are being printed. And the reason why is they already do post-processing on these components. They do a lot of chemical treatments as well, not just heating in like autoclaves to strengthen them, but and in addition, being able to print means that you can actually put certain cavities and you can actually reinforce certain aspects of a shape that you previously couldn't do. something that even like molding them and actually that type of distribution wouldn't be possible unless you were using a 3D printer to get that form out. So I again, the technology is definitely there, especially for the size that you're looking for. A big thing is like being able to offer like that printing farm sort of like aspect where you do have a site that's available that just prints. Something that like, that's what Shapeways, that's their whole business. It's like they're a warehouse, they're just one giant printing site. So as clients order components online, they print them with a certain amount of lead time in there and then ship them. And those come in all sorts of like metals, plastics, and now like certain, even like the cheaper plastics that they're using. So that's definitely something that's available, but in order to offer as like a larger like depot for more industrial like applications, I think that's still like in the works, but companies, like there's subdivisions of, I would say like Stratasys, I think like Red Eye is like one of them, that offers just that. So that's, yeah, I can, all this information, I'm gonna include it in like a little PowerPoint thing to send out at the end of this presentation so that you guys can like look up the resources and find some of these things if you want them. Maybe even like, maybe there's like an entry-level printer or even like an industrial one. I can put stuff out there so you guys can research and look at good articles and figure this stuff out more than just, what we're talking about today. So, yeah.
So what do you think is the next industry that will benefit the most from adopting this?
Well, they said food is going to be the most adopted, and since it's been catching on, I'd still say like food's probably going to be the largest industry. I would say it'd be followed by biomedical applications, the other type of cellular printing, and then soon followed by like consumer products, which seems to get a lot of the hype because that's what people are really familiar with. But in terms of like gross revenue, I'd say like food's probably going to be the biggest. Yeah.
Can you talk a little bit about purchasing the input materials? Obviously, it's going to vary by material, but how it compares to buy, say, the powders versus the raw material in terms of price, whether there's a diversity of suppliers, so if you wanted to do something beyond just prototype manufacturing, you wouldn't have to worry about supply constraints. What does that side of the market look like?
So I would say it's completely saturated with too many suppliers of whatever type of product you want to put in your printer. Which becomes a problem because it's not all of the same quality, it's not all at the same price, and you're kind of at your own risk sometimes when you're putting in some of these machines. I'd say for like the cheaper FDM machines, this is where you've got the widest range. They sell little filament rolls, and we're getting them at $15 a kilogram, because that's how those rolls are. And you can get them at all, like you can get them in half kilogram, full kilograms. You can get them in several pounds if you want, but traditionally, the scale that they're using to measure those, sometimes they cut their plastic with other fillers. You'll definitely know once you start using certain ones, and some cost twice as much. It's still 1 kilogram of the same ABS, PLA type of plastic. When you get to powders, you're still paying by the kilogram, but you could be paying hundreds of dollars per kilogram of that processed plastic that's only certified to be used by that one type of printer from that one company you bought it from.
So there's no standards governing quality, nothing objective that you can say, okay, I'm buying this material and it's going to have X% of aluminum or whatever?
I'm a bit biased. I'm going to say that they have ISO standards, but that really doesn't mean anything to me anymore for a lot of that. And depending on when they were certified and their plans, there are good companies offering good products, and then sometimes you get mixed ones and you're paying the same price for it. So it's a hit or miss oftentimes with it, but if you're buying a more industrial printer, oftentimes that plastic is directly, or the metal powder is directly coming from the same company that you got that printer from. And I would say those are a much higher grade, especially if you're paying top dollar for it. Like, $15 a kilogram versus something that Stratasys would offer, same kilogram roll, you would be paying well over $200 for it. It's still ABS, but one works and one may work once every, so many times. So it's you gotta try it out. Yeah.
So I work in food marketing, consumer packaged goods.
Yeah.
And I'm curious, because I'm not in the manufacturing world, can you talk a little bit about the software that you have to use and how usable that is, or how approachable that is from a consumer standpoint, to actually be able to press, print, and create something?
Yeah, if you guys, if you're familiar with computer-aided design, whether it's something by SolidWorks or Autodesk, or Unigraphics like software, and there's a lot of free ones as well, then you've already gotten through the biggest hurdle if you can use that software. And the next step is that you get what we call a slicing engine, and that's what processes the CAD files. The most common ones are an STL file, and that's something that's easily convertible. And the slicing engines, which you have a wide range of software, but some are free, some cost. I'll show you guys a little bit of how quick it is and how easy it is to just go directly from the CAD software to the printer. And it's getting faster and faster. And these still use what we call these little SD cards. So some use like thumb drives, and now they're all getting wireless. So I can just directly tell my printers to print, and I don't have to have any type of connectivity anymore to them. So the next big step is really to get these things to be networked out of it. But in terms of using the software, it's quite easy. If you can use Microsoft Office, really, I'd say it's got a lot less buttons to click on than even the whole Office suite that you're looking for. So it's simpler, but a lot of the stuff, sometimes it's a hit or miss, and it can be gimmicky, but when it works, it works. So, yeah.
You mentioned briefly Organovo.
Yeah.
Do you know how those guys are doing? I mean, that's potentially revolutionary to the history of the world. If they can make that work, are they making good progress, or are they hitting roadblocks? Because a lot of venture capitals are paying a lot of attention to those guys, I know.
Yeah, I think they're doing quite well for themselves right now. They've guaranteed longevity for their own industry, but in terms of humanitarian benefits, I think a lot of investors have seen that, and they've dumped well over several $1 million, tens of hundreds actually, I would say, that they put in there. So they're doing quite well. I got to find the company that actually developed that printer for them. It was a side company, but they've made one for both plant development and also this organ development one as well. So it's a slight transition, but it's really dependent on that printer. And I think it'll soon become more and more common for that type of machine, and that's really their backbone for the company. I think that's what's causing them to do so well.
They evolved out of Mizzou. You can probably find out that information over there. But they're not there anymore. I think they're in San Diego. But they came out of Columbia, didn't they?
I'm not actually sure where they came out of, but I know they are. They're out there in California now.
I think their initial research was done in Mizzou.
Okay. It's interesting to know.
Who was that?
I'm sorry?
Who was that, and what do they do?
Organovo? So they're one of the bigger biotech companies that have this very intricate 3D printer that's specifically designed for layering cells. They have their own deposition technique. So right now they're working on heart and liver tissue. I think there's a few other cells that they're working developing, but the idea is to lay out the right cells in the right place at a micron scale, so that they can actually start printing off living tissue. And it's stuff that you guys should definitely look into. It's kind of creepy to see heart tissue pulsing, but when it's especially still in a petri dish. But they're working on it, and it's something that they're anticipating probably the next 10 years. It's something that they published to have a fully functional liver segment at least that they could use as a transplant. So yeah.
Can you just discuss some of the ag applications that you kind of referred to?
Yeah, so aside from building robots that kind of are sagging right now, the agricultural thing, once at the end of the presentation, you guys can come here and look at it, but there's actually ultrasonic transducers inside here. So our client's actually looking to build a new, what we call an aeroponic system out of it, and we use some 3D printing techniques to simulate soil. Some of that stuff we don't have present here, but we're building some of the framework where we don't actually have to rely on heavy soils that require lots of water. The idea is to actually use transducers to vibrate water, turn it into mist, directly infuse that mist with the nutrients that the plants need, and actually grow them using that manner with a lot less water, something that would be a 95% decrease in traditional agriculture. And so what we have here, so yeah, when you guys see this, it's kind of cool. There's a mist, but you guys can kind of see it when it's coming up. But both of these, they've got a wide range of things like tomatoes, and it's all grown organically. So we tried not to use no GMOs, nothing that would be detrimental to health at any way, and it's all just organic, like nutrients. So the only science behind it is seeing how we can vaporize just the raw materials and directly infuse it with the plants. I'll get this unit turned on. This is actually a light array system. That's once we get, at the end of the presentation, I'll show you guys as well. But using two different types of lights, the T5 fluorescents that are the tubes, and also the red and blue LEDs. The system's actually designed so that we're getting lights from more than just the standard angle of the sun coming directly down. It comes from like a theory of building up like a lot of the triangles where we can stack these systems, and the tetrahedron that's glowing over there is kind of like the base principle of it. But using this method, we're testing to see if we can actually get more fuller plant growth with a lot less lights. And I think a lot of people would say like, well, there's like the inefficiency of the system is because you're just not using enough lights in there, but we're actually seeing very healthy like growth on like initial plants. Some of these have just been like a couple days old, so and they're growing quite well in there. So we're constantly testing and trying it out, but it's just a newer development. So this used to be it's Type A machines. It's just a standard 3D printer, but we've actually put a different clay or paste extruder on the tip. So this was a custom model. But the system's actually designed to use very similar stuff to like chocolate printing, but also like various like clay media, gel-like media that you can print with. Stuff that could be flexible, stuff that could actually contain organic material in it, and it's still an ongoing experiment. But we're using this type of tech where we want to be able to like move on to embedding directly organic materials, stuff like hernia meshes that can be transplanted, and that's like research that we're looking to develop with WashU right now. So those three printers over there, those are the cheap XYZ printing. They're $500 a piece. They use it's an FDM technique. And for like entry-level printing parts, we get a lot of print runs out of them, but they fail quite often. But again, it's really dependent on what's the value of the product coming out of it. If it's worth having the machines fail all the time, but if one of them like three works, then it works. But again, it's experimental, and it's probably like a good entry-level thing, low value that you can try purchasing and it work out for you. But they work for us, but a lot of times fixing them.
The problem with buying a low-value machine is that it gives you a bad taste in your mouth when somebody tries to sell you a high-value machine. Because you go, oh, I know I've experienced that, and it doesn't work. And the reason I mention that is that we are a reseller of Stratus' equipment, and we see people buying low-value machines, and they turn around and get a bad taste.
Yeah, I started off on a Stratus. The U-Dimension, I think is what it was, the new print thing. And that was, at the time, I believe it was like a $16,000 machine. Same print volume, and so I could make the same types of parts, but a lot of consistency with that machine over several years. Something where it only took less than a month for one of these to fail. So really dependent on the parts you're making out of it. And sometimes it's worth the pay for it, and sometimes it's not. But yeah, and that's really like the variables that you get with the printing industry. Sometimes what you're looking for is like switching over like your current process for the technology, and you're looking to actually make a lot of a certain type of product. You may not know it yet, but you may want to actually do something that's of a higher demand than the tech or the printing tech that's available. And so that's where the transition gets a little bit like harder, and but it's something that I want to include that information for you guys in like the PowerPoint that'll be sent out, so that you guys know exactly what it is you're looking for. And I'll include some contact info, so if there's something where you want to sit down, or you want to like shoot me some emails about what you guys are working on, or what type of printer would be best for your situation, or maybe even for like a client or something like that. I'm definitely available. So
great work. So Chico, BK, thank you. This was awesome. We really appreciate it.